Good morning, students. Let us continue with the similar triangle stuff session. If a perpendicular is drawn from the vertex containing the right angle of a right triangle to the hypotenuse. If the perpendicular is drawn from the vertex containing the right angle of a right triangle to the hypotenuse, what does that mean is, if a perpendicular is drawn from the vertex of a right angle, this is the right angle. Perpendicular means from here you should draw one perpendicular line like this. If a perpendicular is drawn from the vertex containing the right angle of a right triangle to the hypotenuse, then prove that the triangles on each side of the perpendiculars, that means this one, triangles, prove that the triangles on each side of the perpendicular are similar to each other and original triangle. Also prove that the square of the perpendicular is equal to products of the lengths of the two parts of the hypotenuse. Square of the perpendicular means this one, AC square is equal to square of the, also prove that the square of the perpendicular, so this is the square of the perpendicular, this one BD is the square of the perpendicular is equal to product of lengths of the two parts of the hypotenuse. So this BD is the perpendicular, and we have to prove that square of the perpendicular is equal to product of the lengths of the two parts of the hypotenuse. Which are the lengths of the two parts of the hypotenuse? These are the two parts. So it is very, very simple. So let us proceed further. Here angle D is 90, here already given 90 degrees, 90 degrees. Right? So nothing is there. Once again I will repeat the question. Triangle, right angle triangle ABC is there. From the vertex of the right angle you have to drop a perpendicular BD to AC. That's it. Now what we have to prove? Now how many triangles are formed? This and this. Prove that the triangles formed on triangle formed is equal to prove that the triangles formed is similar to the original triangle. Original triangle means ABC. This triangle, these two triangles are similar to this original triangle, and also square of the perpendicular. Square of the perpendicular means BD square is equal to parts of the hypotenuse. Squares on the parts of the hypotenuse. So how to proceed further? Let us continue. Proof. What is given here? Angle B is 90 degrees given. Next, angle, consider triangle. First of all, let us write write like this. Angle B is 90, angle BDA is equal to angle BDC. Both are equal to 90 degrees, right? Do you agree with me that this is 90, this 90, because it is given. These two conditions are given. Right, next one. Consider triangle ABC and this whole big triangle and this small triangle. This one. This triangle. ABC and ADB. Angle B is equal to 90 degrees. Angle ABC, you can write, use three letters. ABC is equal to 90 degrees. ABC is 90 degrees. Next. And again, consider this triangle. Consider triangle ADB, we have written ADB. So, angle A is equal to ABC and ADB. ABC and ADB. Angle A is equal to angle A common. ABC is 90, that is equal to here ADB. angle ADB. Both are equal to 90. ABC and ADB. I am considering ABC and ADB triangle. Big triangle and the small triangle. We found that this is 90 degrees, this is 90 degrees, and angle A is common. Right? Therefore, by angle property, means angle postulate or whatever you can say, triangle ADB is similar to triangle. See that the letters should coincide. Letter A is common for both triangles. Next, D letter should coincide with B. Next, which triangle we are considering? ADB and AB, this big triangle. See, that's it. Therefore, this triangle is similar to the original triangle. Next, similarly, ADB and ABC, right? Similarly, means first part is proved. Prove that the triangles formed on something that is similar to the original big triangle. Similarly, we can prove that, you need not write all the steps. Similarly, we can prove that what this triangle is similar to this big triangle. How? By writing all the steps. Angle by angle postulate or property. Now, but let us write at least the letters should coincide. That part you write down. Triangle. Before that, you can write down consider. This part is finished. Consider triangle BDC. Similarly, we can prove that, you write down. Similarly, we can prove that triangle BDC is equal to is similar to triangle BDC. Here D is there and D is 90 degrees. BDC is there, no? BDC, that this angle should coincide with angle B. D and D means D should coincide with B. I am considering this triangle as well as this big triangle, and angle C is common. So CC letters should coincide. When you consider this triangle and this big triangle, letter C is coinciding. So C should coincide with C. This D BDC should coincide with this big D letter. Angle D should coincide with D. What is left over? ABC. We are considering big triangle. Therefore, triangle BDC is similar to triangle ABC. Similarly, we can prove that triangle BDC is similar to triangle ABC. But before that, you write down consider triangle ABC and which two triangle? ABC big triangle and small triangle BDC. Right. Therefore, you can write like this from 1 and 2. From 1 and 2, you can write if two triangles are similar, their ratio or corresponding sides are proportional. From this, we can write this. I am erasing. From this, we can write from 1 and 2. Triangle ADB is similar to triangle ABC and triangle ABC is similar to BDC, or nothing will happen. If you interchange here, nothing will happen. Therefore, triangle ADB is similar to triangle BDC. And this triangle is similar to this triangle we are saying. So, mark this as 3. Now, take the two triangles are similar means the corresponding sides are proportional. From this, you can write here. Actually, theorem is finished. So, okay, one last part is there, no BD is going like this. First part. AD by BD is equal to, next, these two AD by BD, next, last two. BD by DC is equal to, next, AB by BC. Right? I am writing the corresponding parts. AD by BD, AD by this one, these first two letters. Next, last two letters, BD by DC, these two letters. that is equal to AB by AC. Now cross multiplication you do. AD into BC, AD into BC is equal to BD into BD. BD into BD. That is BD square is equal to AD into BC. AD into DC actually. It is AD DC. So it is AD into DC. That means you see here BD square. Square on the perpendicular is equal to square of the parts of the hypotenuse. Is equal to what is given. Also prove that square of the perpendicular is equal to product of the lengths of the two parts of the hypotenuse. Product of the lengths of the two parts of the hypotenuse. These are the two parts, which is nothing but product of the lengths of two parts of the hypotenuse. Hence the theorem. Therefore, you can write from this also AD by first two letters. AD by AB is equal to AD by AB. This next last two letters BD by BC is equal to first and last AB by AC. Next, you can write from these two, club these two, AD by AD into this and this, AD into AC is equal to AB into AB square. So AB square is equal to what? AB square is equal to AD into AC. You started from here, no? AB square. Just remember this. AB square is equal to AD into AC. From where you started? AB square. From here you started, no? So AD into AC. Next, from this also you can write BD square. So this already we have proved. BD square is equal to AD into AC. Now consider this one. What I am saying is already the theorem is proved, but you should remember this part. AB square is equal to, like it is nothing but a formula in geometry. AB square is equal to AD into AC. Complete. Next, in the same way, similarly, BC square is equal to, we are starting from here, no? BCB square is equal to this complete part into this part. CD into CA. Just remember these two parts. AB square is equal to this AD into AC. BC square is equal to CA into CD. And therefore BD square is equal to these two parts. So it is nothing like the formula only. Very, very important problem. They may ask in exam. So that's it. And here how you got this, you can ask. How you got this, sir? BC square means just take this one. Corresponding parts. The letters should coincide. Remember, the letters should coincide. What does it mean? Letters should coincide. The first two letters AD. This already proved. Let us take this one. BD by AB. BD by AB is equal to BD first letters. Next CD last two letters. CD BC is equal to first and last. BC by first and last I don't know. BC by AC. Next, combine these two. BC is there, no? CD into AC is equal to BC square. BC square is equal to CD into AC. I don't know CD into AC. BC square, when you start from here, BC square is equal to CD into CA. CD into CA. That's it. Next problem. So let me continue in the next session. Thank you, students. Have a nice day. Bye.